Hello guys, welcome to the Harvard Lab today. My name is Babatunde and welcome to Objective 10. Today we're going to be talking about solving a multi-step equation which involves natural logarithms. Okay, so what this means is we're going to put our knowledge, the knowledge we learned on logarithm, everything that we've learned previously on logarithm, and we're going to use that sense, we're going to use that knowledge, and we're going to apply that into real equations. Okay, so like equations basically means like when we have to find a particular variable, let's say we're looking for x or y variable, whatever like that. That's what an equation means. So an equation, in any equation, we're always finding something. So in this case, we're going to be finding x, right? Because we're asked to find x equals box, right? Okay, and yeah, let's get to the question. Okay, so let's read the question. This question says solve for x, 2 ln bracket x plus 3, and close bracket equals a 10. Okay, so what I want to do when I'm solving this question is I want to ask myself, how can I remove the ln or logarithm that's attached to the equation? So in this case, we're using a ln in this case, which is ln, right? So we're gonna have to remove this, right, in order to find x, right? So let's start with that. So this is 2 ln x plus 3 equals 10. Okay, and if you notice in the front here we have a 2 attached to the ln. Okay, so this is basically the same thing as saying 2x equals 10. In order for us to find x, we have to remove 2, right? Because 2 is attached to the x, right? And for us to remove 2, we have to divide both sides by 2. So we have to say divided by 2 here and divided by 2. So when we divide this, it will give us x equals 5. Okay, so that's the same thing we're going to do here, right? Because we want x to be alone because we were asked to find x in this case. Okay, so we want to remove anything that's attached to x, basically. And 2 ln is attached to x, and we have to remove 2, right? Because we can't remove 2 ln because it's basically we don't know what we're going to be working with from then, right? So the first step that we're going to do is we're going to ask ourselves what is attached to the ln. In this case, this is the ln, right? 2 is attached to the ln. I now have to remove 2. The same thing that we did here, that's what we're going to do here, because this is the same thing as 2 times ln x plus 3, right? This one over here is same thing as 2 times x equals 10, right? So in order to remove 2 from here, we're gonna implement the same thing we did in here. We're gonna divide both sides by 2 first. Okay, so let's start with that. This is divided by 2, and this place is divided by 2. So when we do that, this is cancelled out, this is cancelled out, and then this turns into ln x plus 3 equals 5. Okay, because we divided 2 and 2 here, so that gives us 1. This is the same thing as 1 times ln x plus 3, and then 10 times 1 is the same thing. Anything times 1 is the same. So ln x plus 3 was equals to times 1 equals ln x plus 3. And then over here, 10 divided by 2 equals a 5. That's how we got over here. Okay, next up, we're gonna have to remove the ln, right? So we're gonna do the same thing that we did over here, right? So in this case, ln is attached to x also, right? So in order for us to remove ln, we have to divide both sides by ln. Okay, so to do that, I just divide both sides by ln here, and then divide by ln here. So when I cancel this out, that's a 1 also, right? 1 times x plus 3. Okay, so this is x plus 3 equals, okay, so one thing I wanna point out is whenever you're dividing a ln, right? Whenever you're finding a reciprocal of a ln, reciprocal basically means 1 divided by ln, right? Or anything divided, basically as long as ln is at the bottom of the fraction, this is the same thing as exponential to the whatever that is up here. So in this case, this will be exponential 1. Okay, this is e to the power 1. So whenever I see any form of equation and you find the ln at the bottom, this automatically equals to e to the power whatever is at the top. Okay, so in this case, this is going to be e to the power 5, because 5 is at the top and ln is at the bottom. Okay, so basically what we did here was divided both sides by ln, and so when we find reciprocal of ln, that's the same thing as e to the power 5. Okay, and so and from here we're gonna have to work with e to the power 5, and to do that, it's not a big deal. We'll just go to the calculator real quick. Okay, so this e find that out real quick. E to the power 5 equals 148.413. Okay, so this is x plus 3 equals 148.413. Okay, so from here we can find x, right? And so for us to find x, we have to subtract both sides. We have to subtract both sides from by 3, right? And so when we do that, that'll be x plus 3 minus 3 equals 148.413 minus 3. Okay, so when we say 3 minus 3, that's a 0. So this is x plus 0 equals 148.413 minus 3 will be equals to 145.413. Okay, remember this is a whole number. This is not a fraction. So we can only subtract it from the whole number side. And so this is same thing as x equals 145.413. But remember, in the question, we're asked to round our answer to the nearest hundred. Okay, so when we're dealing with this, right, we know sometimes we're gonna have a fraction, we're gonna have all these decimal points and all of that, right? And we'll have to round these answers so they'll look smaller, basically. Okay, so in order for us to round it to the nearest hundred, we're gonna ask ourselves, what we have to know what is the hundred, basically. Okay, so after the decimal points, there always comes a number, right? It's not mostly all the time. This only happens when there is a decimal point attached. Okay, so let's look at this case. This is the decimal point, right? This is the decimal point here, and all the numbers after the decimal points kind of tell us which one is the tenth or the hundredth or the thousandth. Okay, so let's look at this. The first number after the decimal point is always the tenth. Okay, so let's put that down there. The second, okay, so how this goes is basically in this form. This is 10, this is 100, this is 1000, right? But this is only when we're dealing with um with the normal decimal numbers, right? Normal numbers, okay? But when we're dealing with decimals, basically, this is basically saying dot 1, 0 0.1, 0 0.01, 0.001, 0.0001. Okay, so this is because for us to find these respective values, we have to divide them by the number that's the that they basically accompany. Okay, so let's say we're finding tenth, right? We know tenth 10, as the name implies, 10 is basically 1 over 10, right? So 1 over 10 will always give us 0.1. Okay, and so the next one after a 10 is the hundreds, right? So basically these are exponents of 10, right? So let's say 10 to the power 1, 10 to the power 2, 10 to the power 3. These are exponents of 10, right? But these ones are negative exponents of tens. Okay, so this is the first negative exponent of 10, which is 0.1, and then the next is going to be a hundredth, right? Emphasis on the th at the end. Okay, so this is a hundredth, which is equals to 1 divided by 100, which equals 0.01, right? And we can notice based on this observation, so this just goes on and on, thousands, 10,000, 100,000, all the way up until infinity, basically. Okay, so this kind of shows us the position, right? So this shows us that tenth, wherever I see a 1, that's the position we're going to be working with. So in a tenth, the position 1 is seen immediately after the decimal point here. But hundredth is seen 1 point after the decimal, right? So this is going to be the hundredth, this second digit after the decimal point. Okay, so look back to this question. So the second digit after the decimal point in this case is 1, right? So in this case, we're going to be working with the number after this digit, which is 3. So we're going to be working with these two numbers, 1 and 3 together, to kind of figure out, like, okay, are we going to have to round up or not? Okay. So what you're going to do is you're going to ask yourself, what is the number after the hundred, right? In this case, we know it's 3. And we're going to ask yourself, is that number greater than or equals to 5, or is it less than 5? If that number is greater than 5, then you can add 1 to the 100, right? So you can add 1 to this, now make it 2, and then this turns into a 0. But if it's not, this turns into a 0 either way, but the only thing is you don't add a 1 to this, you don't add anything, it still remains the same, but this turns into a 0. Okay, so based on our observation, 3 is less than 5, right? It's not greater than or equals to 5. So that means this automatically turns into a 0, and then we don't add any 1 to this. So this is x equals 145.41. So based on this, we've rounded it to the nearest 100. Okay, so let's check out the answer. 45.41. Yeah. Okay, so let's work with another example, mock practice. And yeah, feel free to pause the video if you would like, just to test your knowledge if you want to. Okay, so remember, the first step you want to do is you're gonna shake out whatever is attached to x in this case, right? So first off, let's look at the 7, okay? Because let's do with the smaller ones first before we get to the other ones. Okay, so this is 7, right? 7 is where x is. So we're gonna have to find x. That's the thing, right? I want x to be alone. We don't want anything attached to x, right? And to do that, we have to take away. We have to shake off everything, right? These are like tails attached to it. We gotta cut them off. We gotta like kind of shake them off, right? So 7 is here, and just think of this as a normal equation. Don't let it panic you. Think of it as a normal equation. How are you gonna solve this in a normal equation, right? So what you're gonna do is in a normal equation, if you're given this kind of question, we want to take the numbers that are alike into one part of the equation, and numbers that are not alike to another part of the equation, right? And 6 and 7, they're numbers, right? They're normal numbers. So we can take 7 to this part of the equation. So when we do that, that would be, okay, let me put in the question first. 7 minus 2 ln x equals 6. Okay, so this turns into minus 2 ln x equals 6 minus 7. Okay, so all we just did was subtracted both sides by 7. Okay, so 7 minus 7 is 0, minus 2 ln x equals 6 minus 7. So first off, we're done with x with 7 for now, right? So this is minus 2 ln x equals 6 minus 7 will be a minus 1, right? So this will be a minus 1. Okay, so next up is we're gonna have to remove the minus 2, because the minus 2 is attached to the to the x, right? So remember, we have to remove every possible thing that's attached to x, okay, because we're finding x, okay? So this is divided by minus 2. Now to remove anything that's multiplied with, let's say we got 2x equals 6, right? We're going to have to divide both sides by 2 now for us to find x, right? So when we divide here by 2 and divide here by 2, it gives us x equals 3. So that's the same thing we're going to do here. We're going to divide both sides by minus 2, okay? So that will be minus 2 minus 2. And so when minus 2 divides minus 2, that's a 1, right? So this is 1 times, then x equals, in this part of the equation, we got a minus at the top and a minus at the bottom, right? There's nothing else common except from the minuses, and we know minus divided by a minus is a plus. Okay, so when these two divide each other, that turns into a 1 over 2, so plus 1 over 2 for both of them, right? So for now we're done. So this is ln x equals 1 over 2. Okay, so now we're gonna have to remove the ln in this case also. Okay, and we're gonna use the same approach that we used here, right? So all this means is we're gonna have to divide both sides by ln in this case, right? So when we divide both sides by ln, we get x only in one part of the equation. Okay, so when we divide here by ln, this will be divided by ln. This cancels out ln, and x equals 1 over 2 times the reciprocal of ln. Ln minus 1 is telling us ln minus raised to the power minus 1 is still the same thing as 1 over ln. Okay, so this is same thing. X equals 1 over 2 times 1 over ln, right? And 1 over ln, as I said in the previous example, equals e to the power whatever is attached with the 1 over ln, right? So in this case, what is attached to 1 over ln? The thing that is attached to 1 over ln is 1 over 2. This is the number attached to 1 over ln, right? So this is e. So in this case, this would be e to the power 1 over 2, because 1 over 2, we're going to have to multiply 1 over 2 by 1 over ln, right? And so 1 over ln, we know 1 over ln is equals 1 over ln equals e to the power 1, right? Because we're gonna say this one at the top is dividing ln, right? So what is dividing ln here is half, right? So half is actually dividing ln. So this is the same thing as e to the power 1 over 2. Okay, so this x equals e to the power 1 over 2. So we'll go to our calculator now and find e to the power 1 over 2, e power 1 over 2, plug that in, 1.648, okay? Okay, so 1.648. So x, in this case, equals 1.648. But not so fast. Remember, we have to round the answer to the nearest hundred, okay? And the nearest hundred is basically the second digit after the decimal point, right? Based on what I showed before, the tenth is the first number after the decimal point. The hundredth is the second number after the decimal point, and the eight and the 1,000th is the third number after the decimal point, and like so on and so forth. So it just goes on like that. So the next exponent after 1,000 is 10 to the power 4, which is 10,000, right? That would be the fourth digit, then the fifth digit, and so forth and so on, right? So in this case, we're asked to find the hundredth, right? So the hundredth is 4 here, right? So you're going to ask yourself, what is the number after 4? So in this case, the number after 4 is the 8, right? I'm going to ask yourself, is this 8 greater than or is it less than 5? Okay, so in our case, 8 is greater than 5. We know 8 is greater than 5, right? And so if that number, which is 8 in this case, if that number is greater than 5, we can add 1 to the hundredth itself, right? So we'll add 1 to the value that's occupying the hundred space, which is 4, right? So we'll add 1 to 4 and then put this to 0. Whatever that comes next will be every one of them will be 0. Okay, so this ends at x equals 1.64 plus 1, 5, right? 1.65. Okay, so let's check that out real quick. 1.65. Yeah. All right, so thank you very much for watching the video. I really hope they helped out, and yeah, have a nice day ahead. Bye.